United States Department of Energy. I'm Emil Nussbaum and I represent the Automotive Recyclers Association. Since 1943, the Automotive Recyclers Association has represented professional automotive recyclers. Professional automotive recycling facilities play an important role in the vehicle repair market by providing vehicle owners with cost-effective alternatives to more expensive new original equipment manufacturer replacement parts. Professional automotive recyclers supply recycled original equipment motor vehicle replacement parts to consumers around the world. In addition to the critical role professional automotive recyclers play in the automotive supply chain and replacement parts market, professional automotive recyclers play a valuable role in the efficient, environmentally friendly recycling of end-of-life vehicles. Professional automotive recyclers are the largest collective owners of end-of-life vehicles and are subsequently the largest generator of source material for scrap metal recyclers. Automotive recycling preserves natural resources, reduces the demand for scarce landfill space, and plays an important role in reducing air and water pollution. Automotive recyclers are already the largest collective owners of end-of-life internal combustion engine vehicles and are the primary facilitator for their reuse and recycling. Therefore, automotive recyclers will become a key party within the electric vehicle and lithium-ion battery life cycle and will be a primary facilitator for their reuse, repurposing, and recycling. According to the Argonne National Laboratory, between 10 to 15 million end-of-life vehicles are retired from service each year and enter the domestic recycling infrastructure. Out of the 10 to 15 million end-of-life vehicles retired each year, a substantial majority of those vehicles go to automotive recyclers. As an industry, automotive recyclers will be the main facilitator and sorting mechanism for end-of-life vehicle batteries to be reused, repurposed, and recycled. Automotive recyclers will need to be able to evaluate the state of health of battery units and will need to develop the certification and skills necessary to safely handle end-of-life vehicle batteries. The most popular challenges identified by automotive recyclers when handling end-of-life vehicle batteries are safe handling and removal, knowing what tools and PPE will be required, how to pack and store them, how to get paid for EV batteries suitable for reuse, and how to pay for proper recycling. To address these challenges, ARA has been actively developing training and resources for automotive recyclers. For over 20 years, the Automotive Recyclers Association has worked on providing certification and training to the auto recycling industry through its Certified Automotive Recycler program. In the absence of a formalized training program provided by vehicle manufacturers, the Automotive Recyclers Association has endeavored to collect safety information to create a training program that is freely accessible to all automotive recyclers. ARA and its certification committee has been helping automotive recyclers learn more about processing electric vehicles through the publication of training modules in an electric and hybrid vehicle training technology guide. The U.S. Department of Energy can help ensure that automotive recyclers can help facilitate the reuse, repurposing, and recycling of end-of-life vehicle batteries by assisting ARA in its work to develop training programs and resources for automotive recyclers handling electric vehicles at their end of life.
Global Battery Solutions is a battery lifecycle management service provider. Our role is to assist our customers with one, fully utilizing the energy and materials that go into batteries initially, keeping them safe in vehicle as long as possible. Secondly, building safe and efficient second use opportunities for batteries after vehicle use, including energy storage systems for decarbonizing the utility grid and supporting its resilience as electric vehicle charging needs continue to increase. And thirdly, identifying end-of-life cells, discharging their energy to the utility grid and getting those assets to high material recovery rate domestic recyclers. Our job is to endeavor each day to build a robust and resilient reverse supply chain for batteries. Global Battery Solution is a battery innovation laboratory with IP and patents in wireless vehicle charging and a technology for battery monitoring, tracking, and integration with control systems, performing R&D and developing technology-driven solutions to support our core battery lifecycle management work, as well as the work of other key stakeholders in this industry. As an operator in the reverse supply chain, providing critical support in logistics, storage, and warehousing, Global Battery Solution is very aware of industry pain points and accelerating costs that threaten to impede the current trajectory. We recognize the strategic security imperative to ensure that automation, 4.0 industry, and advanced manufacturing are used to move batteries efficiently and safely throughout their life cycle, keeping cells in the United States so we retain precious materials for new battery manufacturing potential. Global Battery Solutions invests heavily in workforce development initiatives with local public schools, community colleges, and universities. Additionally, we are engaged with underserved communities in our region, providing retooling and training, upskilling for adults who want to participate in this exciting growth industry. But we must move quickly and strategically to ensure that new collar job development opportunities are accessible by all Americans and that no communities are left behind.
I'm Bob Mulaney. I'm the CEO of ITAP. The key to the battery industry is extending its life as long as you can and putting them in second life applications to live out their life cycle.
This is Marshall Neipert, Chief Technology Officer of IT Asset Partners. After investing $12 million into R&D, we have successfully built second life solutions for all lithium batteries in the United States. At ITAP, we use the past to power our future. Lithium batteries can last 10 to 20 years depending on how they're used, but most are discarded within 5 to 7 years. These two mugs represent lithium-ion batteries. This mug represents the scrap recycling solution, and this mug represents reuse. This still has value. Now let's look at the scrap recycling solution. Do you see the difference? And if this is LFP, the taxpayer has to pay to get rid of it. Everybody knows the tsunami of EVs is coming to America. The question is, what are we going to do with the batteries? Electronic waste in our landfills is responsible for 70% of the heavy metals leaching into our water table. Only 17% of e-waste is recycled in America today. But what if there was a better answer? What if there was an innovative solution that could benefit everyone? What if we could retain the value of the lithium batteries? Reduce, reuse, recycle. We are all told this as children, but where's the reuse in America? In 2017, ITAP realized that EV batteries would become the largest single volume of low-value hazardous e-waste in the United States. ITAP is actively paying our customers for lithium batteries, including LFP, while processing all EV battery waste domestically and maintaining a zero landfill policy. We are requesting support to expand these second life solutions nationwide and automate the process to create true sustainability for EV battery waste within the United States. Reuse makes things affordable. It provides abundance in a world of scarcity.
All our products are returned here, made here, and moved out into the market as US-made products.
The choice is ours. We can incentivize recyclers to reuse or fund a doomed scrap recycling system.
So the message I have for you, the DOE, is if you want to put the time and effort, we're your partner. We've invested in the technology, we understand it, and we know how to do it safely.
As you decide how to allocate this funding, we hope you consider reuse as the true sustainable solution, turning our country's lemons into lemonade. Thank you for your time.
Hi, my name is Jonathan Dwan with NuVant Systems, an A3 global company, and I'm here to share a little bit about battery lifetime cycling. Over the past 7 years, NuVant Systems has been a leader in battery reconditioning technology, and our equipment can be found in shops and businesses worldwide. Since 2015, our EVC battery cyclers have processed over 25,000 hybrid battery packs. Our system increases nickel metal hydride battery lifespan and balances the battery packs, allowing them to be put back into hybrid vehicles for additional years of use. We're currently focused on expanding into lithium-ion batteries and electric vehicles. This effort continues at our facilities in Crown Point, Indiana, Boston, Massachusetts, and Phoenixville, Pennsylvania. To adapt our current hybrid battery remanufacturing for electric vehicles, we must address battery life cycles for environmental, supply chain, and full value utilization. Based on the performance evaluation, the batteries will be designated for extended use in vehicle or second life applications, such as solar panel energy storage. This will divert the hazardous remains from landfills and destructive recycling. The first challenge is developing proper equipment and cycling protocols that are safe for lithium-ion batteries. We know that lithium-ion processing is more dangerous than nickel metal hydride processing due to the flammable electrolyte. We need to institute proper safety precautions not only for the remanufacturing process, but also for their use in the extended and second life applications. Another challenge is the fact that there are many different types of lithium-ion chemistries used, as well as many different battery formats and specifications. Here I've highlighted the top 5 battery chemistries on the market, and you can see that lithium manganese oxide and lithium iron phosphate make up the largest percentage. To properly address this, we would need to create a full library of various lithium-ion chemistries and of all the battery formats on the market. Thank you. Please visit us at www.nuvant.com and www.a3global.com, and my contact information is below.
Hi, I'm Kunal Falfer, the Chief Strategy Officer here at Li-Cycle. We're a lithium-ion battery resource recovery company listed on the NYSE. Our main goal here is to recover critical materials from spent lithium-ion batteries or manufacturing scrap to close the loop in the lithium-ion battery supply chain and do that domestically or locally to support onshoring of a supply chain. How are we doing that is really through 2 core pieces of technology, what we call our spoke, which shreds any of those types of materials from manufacturing scrap through full EV packs into intermediate materials, and our hub, which then refines some of those critical materials into battery grade products such as lithium carbonate, cobalt sulfate, nickel sulfate. And how are we deploying our assets? Well, we have 2 existing assets built in 2020, one in Kingston, Ontario, one in Rochester, New York, both of our spoke facility. We are 3 spokes under development in North America, or in the US actually, in Arizona, Alabama, and Ohio, the last of which will be directly on the Ultium Cell site to manage their scrap and recover intermediate products on site, thus benefiting from savings in logistics and packaging. We're also building our first commercial hub in Rochester, New York. That'll be operational in 2023 and will be able to produce those critical materials in large scale. What do we need and what have we learned over this time? I guess a couple factors that will continue to develop or evolve, one being permitting, and streamlining that, as each state we've seen has different process, different timelines, but this industry is moving quickly, electrification is moving quickly, and particularly spoke deployment needs to move quickly as well. Additionally, workforce development is an important factor. We have a diverse workforce from operational staff through engineer, process engineers, chemical engineers to operate the hub. And having access to those employees in different regions of the country will be an important factor moving forward. So just to conclude, high level, Li-Cycle has a scalable technology, economically sustainable through the high recovery rates, and environmentally sustainable with a low footprint relative to critical materials coming from primary resources. I'd like to thank you for your time and look forward to continued discussion.
Hello, I'm Tom Schaefer. I'm Ecobat's Vice President for North American Lithium. Ecobat is the world's largest lead-acid battery recycler. We're headquartered in Irving, Texas, and we have operations throughout the United States, as well as in Europe and in South Africa. Today, we're working on scaling our lithium business, both here in the US and in Europe. In Irving, Texas, we have a pilot plant that is demonstrating for R&D purposes all processes of lithium battery recycling, from battery input and diagnostics all the way through to black mass production. In Europe, we have commercial operations which are capable of diagnostic sorting all the way through shredding and black mass output. Ecobat's goal for the United States is to have a commercially viable facility up and running by the end of 2022. There are several challenges that we face as we approach this goal. The first challenge I'll discuss is the regulatory environment. Dynamic regulations can be cumbersome and add additional risk to companies looking to scale operations such as Ecobat. While health, safety, and environmental stewardship are at the core of Ecobat's business, there must be a fair balance with the freedom to operate profitably in an open forum for regulatory feedback. Second, the large-scale machines required to shred and refine the battery materials are relatively scarce and have been severely impacted by the supply chain issues of the last 2 years. Capital requirements are increasing, which is rebalancing the economics of such an operation. Last, but certainly not least, the challenges of the labor environment are certainly impacting our business. Top-notch EHS is one of our core principles, and lithium batteries present a number of unique and very difficult challenges. Personnel retention is required in order to maintain a top-notch safety environment. Between 30 and 100 operators are required per plant, plus additional office and back office members of personnel and administration. Each person requires several hours of training, as well as additional recurring training to keep that safety record top-notch. Improper disposal of lithium batteries is not only wasteful and dangerous, it impacts America's strategic positioning on metals required for high-density batteries. Many of these batteries are mined exclusively and refined exclusively in places like China and Russia. So maintaining a competitive advantage here in the US by circularizing that economy is vital to national security and national interests. Thank you for your time today. Ecobat is working on a sustainable, secure energy future.
Did you know 60% more greenhouse gases are emitted, making the battery for an electric vehicle than the engine for a combustion engine vehicle? I'm Amanda Hall. I'm a geophysicist. I'm the founder and CEO of Summit Nanotech, and we're here to fix that at the root of the problem, which is lithium mining. Lithium miners face many challenges in the field today. They have poor yield, high costs, and it takes 18 months to get the lithium from the ground to the market. We have an industrial scale solution that works in all sorts of resource types. We double yield, we lower costs, and we get the lithium to market in a day. It's like a bullet train for lithium. On top of that, we reduce land use area by 26 times. We use no fresh water. We create 90% less chemical waste, and we cut greenhouse gas emissions by 50%. We're future-proofing mining operations. The price of lithium has skyrocketed because demand has outstripped operational supply. We can help fix this problem by developing new projects in the United States, in California and Nevada and Utah. Our technology is modular. We get as close to the resource source as possible so that we transport product instead of waste. We've created 2 technologies, one that creates a lithium carbonate product that feeds into LFP cathode batteries, and one that feeds into NMC cathodes that go into NMC batteries. Our first process is called Denali C. It makes lithium carbonate. We invented lithium selective sorbents that pull lithium out of solution like a lithium selective sponge. Our second process is called Denali H. It creates lithium hydroxide. Here we use a lithium selective membrane that acts like fly paper, and lithium sticks to it. The lithium hydroxide process also works in the lithium-ion battery recycling space. It's also perfectly suited for clay and clay resources. Compared to our competitors, we use much less acid and base in our lithium process. Bloomberg ranked our technology number 1 for sustainability, economics, scalability, and product grade. We have a team of 32 resource extraction experts, and we've won multiple awards internationally. Together with our investors, BHP, Capricorn, and Temasek, we are scaling up our technology as quickly as we can to commercial scale. Join us by thinking about the mine of the future so we can set new standards for lithium extraction today. Thank you very much.
Hi, I'm Steve Sloop, the founder and president of Onto Technology. We're located in Bend, Oregon, where small companies develop the world-leading technologies for recycling of lithium-ion batteries. We have a patent portfolio that's comprehensive for intelligent recycling of lithium-ion batteries. And we're in the NatBat top 10 emerging companies, the Department of Energy Made in America Battery Recycling Prize finalists for phase 3. And really pleased to have the opportunity to be at this point in the United States with the transition towards carbon-free and carbon-neutral technologies for transportation energy storage. It's a big challenge. All you have to do is look at a parking lot and see and do the simple math. We got a long ways to go. And the Department of Energy and the federal government has embarked on a really important project here to invest in advanced battery recycling. And we have an excellent opportunity here to invest in small companies, to make them big companies, and implement technology that is necessary for the economic and environmental sustainability of electric vehicles, enable the use of common materials that are present in America, and implement intelligent engineering solutions for clean energy and a carbon neutral future. So we have to find a way to get small businesses involved with these rather large grants. And so that's not going to happen on our own. And we are looking for industrial partnerships, deep pockets to partner with the federal government and implementing these important infrastructure needs for the next century. Thanks.